Welcome back. Today we are going to take a look to this small exercise, but it is a great example of for show how to keep a strategy consistent as well as the manufacturing approach for our designs. Alright, so this model is capable to change the diameter of the tube and keep this tap consistent. We can go as huge or big diameter we want, as well as go as small as the tap let us to have it without having an inconsistent, of course, geometry. So let's jump into the details how this model had been done. For that I will go to the model, and now I'm going to show all the sketches. Okay, so the strategy consists on create the sketches that are going to be in between them. There are some references, projections, and parameters shared everywhere, to be honest. Proof of that is if you look at this parameter table, you can see all these parameters done already. So I'm basically controlling the diameter, the thickness, the dimensions of the cut from the top, as well as the thickness that we have, or well, no, the resultant of the tool pass cutting material. So it will depend on your manufacturing process, if it is laser or if it is by milling. Okay, so let's jump into the first operation, that it is as simple as just a tube by itself. Then we got a cut from the top. Later we have the creation of a body, a separate body, and here's something about the strategy. So as you can see, I have an offset that is 1.5 in this case, but it could be less or more depending on your manufacturing process. And I'm on purpose leaving a gap in between those two. The idea is to have enough space for make the bend of the tap without creating a problem. Because if I just leave a small material, let's say, or even the second solid body totally touching this face, when we rotate this tap at the specific angle, we are going to have a collision, or let's say a penetration in between the two bodies, and that's going to be inconsistent for our method to make the bend. The thing is that this is a round geometry bend, so it's a little bit tricky. Okay, let's jump into the second operation, that is basically the rotation of the tap. If I go to modify it and go into the select axis step, you can see why I have these lines in here, and they are basically for provide reference to my rotation point. So the resultant of this is going to have this point of the second body lower than the original position. That's consistent with a manufacturing process. Then I have a sketch here in the middle, because this one is impossible to have it at the beginning of the Model 3. But yeah, it is basically the projection of this face. Look at this sketch is independent from the geometry of the face of the tube. This is really important in order to avoid crashes in your model later when you are modifying. Okay, then I got a loft in between them, having of course normal to face condition, normal to selection, so that's going to make them like tangent. and this thing is going to be consistent, especially because we are taking care of this space. This space in my model is the same as the thickness, so it is parametric. If I change the thickness of the tube, this gap is going to be modified. Okay, the next operation is to combine both. So we have the combination of both. Now we have one single body, which is what we wish. And finally, I added some rounds that are clearly happening when you have a manufacturing process, right? So one of the things that I like from this approach is that we can, let's say, animate, explore, or take a closer look what happened with our tap, because we need to have enough space for the rotation to make sure that we are not colliding. Let's say if I leave a super small gap in between the bodies, and because this is 6mm diameter thickness, probably the bend cannot happen because it could be potentially colliding with the thickness of the rest of the tube. But in this case, it's not the case. In this case, it's working really well. Okay. So there you have it. Let me know in the comments what do you think, and don't forget to subscribe and comment and leave a like. Thank you. Cheers.